The topic is Helm. We will discuss what is Helm and I will explain you step by step how I implemented Helm and deployed application using it. My application Resume Matcher is a multi-tier Node.js application that has the front-end, back-end and database with API keys to help it run. I have used GitHub as a repository to pull and push my application deployment with the help of Helm repository and its charts and templates. We will discuss all of this. Let's begin. First, let's understand what is Helm. Helm is an open source package manager for Kubernetes that automates the deployment, scaling, configuration, and management of applications within a cluster. It functions similarly to a traditional operating system package managers like apt, yum, or homebrew, but it is custom built to manage complex Kubernetes YAML manifest as a single version unit. So simply, Helm is an open source package manager for Kubernetes. It helps in automating the deployment, scaling, configuration, and management of application within a cluster. The core problem Helm solves is when we deploy an application via Kubernetes, we would be manually writing and executing dozens of distinct and different YAML files like deployment services, configuration maps, and all of these YAML files, and perform the command kubectl apply to apply those and create a deployment pods. While this is a great step, but managing these files across different environments like development, staging, and production often leads to hard-coded configurations, duplication errors, and complete lack of deployment history. So Helm addresses this issue and problem by bundling the configuration files into customizable and parameter-driven application templates. So Helm charts and building your application around Helm has certain templates and charts and values.yaml files. So you build your application around those parameters, so you don't have to change your deployment and other configuration files or many configuration files, and you only need to update or prepare values.yaml. I'll explain that while performing the project, but let's first understand the three big concept in Helm. Helm operates using three core components outlined in the Helm documentation. First is charts. Helm charts is a structured bundle of YAML template files that fully defines a set of related Kubernetes resources or simply your resources of application. And second is repository. It is a public or private collection point where Helm configurations are stored, versioned, and shared. For example, it can be in the artifact hub or it can be into the GitHub repository. Third is release. It is a living active instance of specific chart or configuration of Helm which you have created, deployed into your Kubernetes cluster, meaning you prepare certain configuration files with respect to Helm and its templates, all of it, and that serves as a living active instance when we deploy that into the cluster. So you build your application around Helm, prepare charts, templates with respect to your default configuration YAML files, and push that into the repository, for example artifact hub or GitHub repository, and it builds a living active instance of that application. And you bring that application by performing Helm repo add or by Helm installing after adding that repo into your application or the folder using the CLI. Now let's understand what are the key benefits of Helm. First is dynamic template engine. Instead of copying entire YAML directories and its configuration for different server environments, Helm uses Go template logic, meaning you change a single file called values.yaml which is present inside your packaged application folder. That values.yaml is to produce or populate dynamically configurations like replica counts or environment passwords, meaning you would obviously be having certain YAML files before reaching the concept of Helm. For example, if you have deployed your application using kind and multi-node cluster or single node cluster using Minikube, so you would be having certain deployment files, ingress files, service files, and you certainly would have port forwarded at least, or you have created load balancer to run that application on ports. So if you have done that, you would be having certain YAML files. Now with respect to Helm, you don't use those YAML files or those all configurations directly, meaning you would update your existing YAML configuration to not have hard-coded values, meaning you will be preparing and updating all those YAML configurations to have placeholders or keywords, and those keywords would be directly added into the values.yaml file. I hope it makes sense. So values.yaml would be having that keywords and you specify those values in the values.yaml. meaning you don't have hard-coded values inside a deployment or other configuration files. You will be having a single values.yaml file that would have those values specified inside it. So all those configuration files would act as a template to the values.yaml file that has the actual values and keys for that configuration files. But here's another thing. If you are intending to create or prepare values.yaml file, that's great. You can add all those values, meaning environment variables and everything. But if you are preparing it and planning to deploy it on the GitHub repository, which is to be public to perform Helm project of this, then your API keys will get revoked if it is a public repository. So simply values.yaml will have all those values that are required or to run. Now, if you plan to have a public repository and you add those values.yaml inside a public repository, meaning those API keys will get revoked, and it is not a best practice to have your secrets or API keys exposed into a public repository. So instead, you can create values.yaml with all of the values in the deployment configuration or other configurations, but you can create another YAML that would be values override that would have all the API keys or confidential variables in it. So you have values.yaml that would have configuration related information of your other configuration files, but doesn't have the confidential or secret or API keys related information, and you will add certain placeholders and variables inside that section of API keys or confidential information that is not supposed to be in the public repository. So you would create another YAML in the root folder that would be having API keys or such values that are confidential, and that would override the values.yaml. So you will be having values override.yaml to override the values.yaml file. So meaning you will be deploying or pushing your application on GitHub, but you will not add values override that would have the API keys in it. So you will add values YAML, all those other files, and you will create values override YAML in the root folder, but you will only use that values override as a key to the lock that is your application. There is a certain command I will explain you in the project section. We will install the application by using values override as a key explicitly locally. So you will not have values override deployed anywhere. You will have that file values override locally, and you will use that file as a key to override and install application with respect to it into your local machine. So that way you have your secrets or API keys related variables defined in values override, and it will run your application smoothly, and it will not give you errors or revocation of your API keys if you had them publicly in the open repository or public repository. I hope it makes sense, but I will explain you further in the project section explaining this. You will get more idea of it. So simply you can understand Helm and its repository concept as Play Store. Instead of building or preparing application and its deployment files one after the other for new projects, we can package the application, prepare Helm charts and everything. We can test that by running the application on port forwarding or load balancer. If it is working, that's great. And we push that application into the repository and we prepare the Helm repository and Helm install. So what you have prepared would be like an application, just like an image, meaning when you deploy into the Helm repository and also install your application with respect to it, instead of you preparing all those deployment files in other projects, you would directly be running the pods while installing from the Helm repository. I hope it makes sense. So you will not be copying all those configuration folders files and add them into your new project. Instead, you will package the application once for all, and you would perform Helm install, and you will have that pods and deployments running while you perform installation of your application with respect to Helm repository. So that was about kind of theory part of how Helm repository works. Now let's understand and see how I have done all of this step by step. So first step to perform Helm or to begin this project, to create the cluster, I'm using kind multi-node cluster. As you can see, this is the YAML file of kind node YAML, which means it has one control plane node, which is master node, and 3 worker nodes. Then I perform the command kind.exe, create the cluster with respect to the configuration file which I have created, that is kind node YAML, and the image I am using would be kindest node version 1.27.3, and it is created. We can perform and confirm it by kind kubectl get nodes -override. The nodes are up and running. After we have created the nodes and the cluster, let's now create Helm Helm repository folder, and inside that Helm repository another folder that is resumatcher. I perform this on the root of my project folder, meaning after this command I will be having a folder that is Helm repository. Inside that folder would be another folder resumatcher, and cd Helm repository to get into that Helm repository. After this, the command is Helm create resumatcher. Resumatcher is the folder which I have just created inside the Helm repository. As you perform Helm create with respect to your project or folder name, this command will create templates Helm ignore, chart.yaml and values.yaml. I already had deployment and other configuration files from my other projects of resumatcher, so I have just copied and pasted them in the template folder. And one more thing to remember is I have not provided all those YAML configuration screenshots or details how I updated it, but simply you have to update these configuration files of yours with respect to your application in such a way that it redirects them into the placeholder values of values.yaml, meaning you will have certain keywords. Instead of you mentioning or specifying it in the deployment YAML, you will redirect those values inside values.yaml. So values.yaml will have all those specified details, not your templates folder. So as it says, it is a templates. It will have the structure of your application, not exactly the values, and values.yaml will have the actual values. And if you have certain confidential values such as secrets or API keys, you can create another YAML file which is values override, or you can name it anything .yaml, which will act as a key value install, and it will have all those confidential keys and related information which you will not add them into your public repository. It will act as the key for you to perform and run or install Helm repository locally. So simply this is the template folder. Now next you can see I have pv YAML, that is persistent volume claim YAML file, and as I mentioned values.override YAML file, which has all the related API key information of my application which I don't want it to be present in the public repository. This values.override YAML will act as a key to my application, and .git ignore has values.override.yaml mentioned, so it doesn't accidentally push this file into the GitHub repository. As you can see, .git ignore has this values.override YAML, so it doesn't accidentally add this YAML file into the GitHub repository. Now we will understand the values.yaml file. As I mentioned, values.yaml file simply consists of values you don't specify in the other configuration files inside template folder. So typically your deployment configuration or other configuration file has all these details which is to be mentioned inside the values.yaml. So templates only have structure and templates or with placeholder values, and this values.yaml will specify those information which is missing there. So your Helm repository will rely on values.yaml to prepare the application. This values.yaml and all this template thing is to simplify the deployment and creation process. Typically you would need to update all those configuration files one by one, but in this case you only need to update the values YAML file and its values, meaning you can scale up or down, change the CPU capacity, memory capacity by just changing values YAML file, not your other YAML configuration files. So first it is app replicas, meaning two parts of application deployment. Image is within the repository GHCR, GitHub Container Registry, my username Kaif Ahmad Khan, and resumatcher DevOps. So I already have pushed image of my application in a private GitHub Container Registry, and I have mentioned that tag is latest, image pull policy always, and image pull secrets, that is GHCR secret, meaning I have created a secret, GHCR secret, that has personal access token to access this private GitHub Container Registry. If it was a public container registry, I wouldn't need GHCR secret to access it. As it is private container registry, I need GHCR secret. It contains personal access token to access this repository, and these are related to ports, environment variables, resources, CPU, memory, database related information, image, PG vector, PG50, persistent volume claim PVC, that is name, Postgres PVC, storage class standard. And here is the important part. Here I mentioned secrets with all those placeholder values, that is DB secret, Google API secret, and all this information. Now you would assume that you should have mentioned the secret values here, meaning you should have mentioned the API keys, DB secret here as it is a values.yaml file. Your observation is great, but as this deployment file or values.yaml file will be in the GitHub repository public, even private, so it shouldn't be that your values are exposed that way. So instead I created the values override.yaml that has all those secrets, keys, and its values mentioned in it. So it is the file that is not present in the repository or anything. It is only present in the root folder, and I can only access it locally to install it with respect to Helm. And next is configuration map and its information and its values. This is all related to database configuration. Service type is node port. So that was about values.yaml file. I mentioned that it has secrets section which doesn't explicitly specify the values of secrets, meaning it doesn't have API keys and everything or DB secret mentioned in it. It has values override that overrides this as a key which I will use to access the application locally. After this, the command is helm package resume matcher, and you can see successfully packaged the chart. And next is helm repo index dot the URL with respect to my GitHub repository, that is helm repository. After we perform these commands, we can observe that resume matcher tar gz while is present and index file is also created. After this, now it's time to push application into the created empty GitHub repository, meaning I already have created Helm repository which is empty. Now we will push those configuration and these files inside that repository. So first let's confirm the origin. We can observe that it is present in the resume matcher DevOps origin. We need to change it to Helm repository in order to push those files. So I performed git remote set URL and this command. We can see that now it's changed to Helm repository. Then I performed git add dot git reset values dot override dot YAML, meaning it will add everything but it will not add values dot override YAML. As I mentioned, reset command. We can see git status that on branch main these are to be committed, meaning all these files. And I performed the command git commit -m with the message performed git push without values override dot YAML because it has API keys and confidential information which is not to be present in the repository. It should only be present as a key inside your local folder. After committing the git, then the command is to push origin main forts. It was successful. However, as you can see in the Helm repository of my GitHub, all of the files which is inside the resume matcher DevOps, not specific to the Helm repository, all of it is pushed inside my Helm repository, which shouldn't happen. My only aim was to push Helm repository which had 5 to 10 files in it, but it has pushed all of the root folder of resume matcher DevOps inside this Helm repository. In order to fix it, I perform the command git subtree split prefix helm repository be helm repo branch, and I created the branch helm repo branch. Then I pushed origin helm repo branch main force, meaning only helm repository folder will be pushed. After this, we can see that all of the other files are removed and we only have the required files, which is resume matcher and all these folders index.yaml. Inside the resume matcher, we will be having templates folder and other folders as well. After you successfully add the required files of yours within your created repository of Helm, the next step is to get into the pages section of your repository and update the branch section to main. After you change it to main, save it. After this, the next command is to helm repo add. You can give any name. I have given it my application name, that is resume matcher. You can give it resume matcher version 1, your application name version 1, version 2. Next, it is to specify your GitHub account username. You can change the username with your username. I will be specifying it with Kaif Ahmad Khan with the Helm repository and Helm repo update. After performing Helm repo update, it is successfully updated. I performed Helm search repo resume matcher. Resume matcher is present inside the repository. After we successfully added our application into the repository and locally to your folder or application. Next is to perform the installation. The command is helm install. The name you want to give, I have named it resume matcher service space resume matcher slash resume matcher -f values.override.yaml. As I mentioned before, I haven't specified explicitly all the values inside the values.yaml. So I needed values.override.yaml to act as a key that has the specific and the required API keys and secret information. So to do that, I have performed -f values.override.yaml, meaning it will install with respect to the values.override.yaml files. It was successful and it was deployed, but we can see the pods are still in the pending state, meaning we have specified the API keys and secrets with their names in it, but we haven't actually created secrets. We can see that one secret is missing. We have DB secret, API secret, CX secret, which is great, but one secret, that is GHCR secret, with respect to my image GHCR private repository, is missing, meaning private image in the GHCR which I am using to build the application here is missing. Even if one secret key is missing, yours will be in the pending state. To fix that, I performed the login first into the GHCR by echo space personal access token and this command with my username, password, and it was successful. Then I created GHCR secret, which is present in the values.yaml and inside the values override.yaml. After it was successfully created, then I confirmed the pods by performing kubectl get pods -w. We can observe that now the pods are successfully running as we have created all the required secrets, and it also has the API keys that we have specified inside the values override.yaml. After we observe that pods are successfully running, the next command is to perform kubectl port forward service slash resume matcher app port 8080 map to 3000. Application deployment would be running on the port 8080. As we can see in the local host 8080 application UI is available. I will add my resume and see if it works or not. It was matching the resumes and it provided the results, that is match jobs. We can see the application is successfully running while installing it with respect to Helm install. We can see the company name and all the job. Let's see the logs. I performed kubectl logs -f with the application pod. We can see the logs Google API key, meaning API keys is loaded and all those information, indexing, embedding with respect to the application. And in the next talk section, we can see that the title, the job title and other information is available. And it also shows my name, that is Kaif Muhammad Khan. It is due to the database configuration I have done. So I successfully managed to pull off this Helm repository charts and this concept. You are seeing just the result of the application, not the debugging which I have performed and failed few times, meaning it took me around 1 week to actually make it happen. I had a deprecation of the API keys while performing this project, so I had to rewrite all the configuration of my application in the backend and rebuild all these images. First I rebuilt the Docker Hub image and I pushed it there, and I created CI/CD pipeline of GHCR private image which you have seen in the values YAML. I built and pushed that image. After fixing the API keys and the backend issue, it took me like around 1 week to even realize that it was the API keys that was causing the issue. So it was a really roller coaster ride while performing this project. I hope you understood and had the idea. You can let me know in the comments if you have any questions. So that is it for the video today. Thanks so much for watching. Have a good day. Bye.